What if your VEX IQ robot could tell when an object is too close or too far? In this video, I'll show you how to build a keep your distance robot using the distance sensor. This is a great beginner project because it introduces a really important robotics idea. Instead of reacting to just one condition, the robot is trying to stay within a range. In this project, you'll learn how to read the distance sensor, store the distance in a variable, and use if, else if, and else statements to decide whether the robot should move forward, reverse, or stop. Here's the full program that we will build. The logic is actually very simple. We're just checking if the object is too far, or too close, or in the middle. Let's define our three zones. If the object is less than 30 millimeters away, the robot thinks it's too close, so it reverses. If the object is more than 70 millimeters away, the robot thinks it's too far, so it drives forward. Anything in between is the good zone, so the robot just stops. I'm starting the program by setting the drive velocity to 25%. This block can be found right here. I want the robot moving slowly for this demo because slower motion is easier to observe and easier to tune. Next, we have a forever loop from the logic section. The forever loop is useful because we want to continuously check the sensor readings over and over again. That way, the robot can continuously react as the object moves closer or farther away. Now, I want to read the distance sensor and store that value in a variable called dist. Let's first make a variable called dist. Click on Make a Variable and enter the name for your variable. Click Submit and you have a new variable here. Drag the set dist block into the forever block, and here we want to set it to the distance that's read by the distance sensor. Under Sensing Distance, you'll find the object distance in millimeters. Now, why did we create a variable here? We're going to reference this variable multiple times within the if and else statements, so creating the variable helps us reduce the number of times that we have to ask the distance sensor, hey, give me the distance. We just ask it once and we store it in this variable called dist, and after that we can just use this distance variable. It is very important to set this distance variable inside the forever loop, so that when the loop repeats, you are updating and refreshing your distance values. Now for the decision making, this is the core functional part of our program. Let's go to logic and grab an if then else if else block. The order of conditions that we'll check here is if the object is too far, else if the object is too close, and naturally else just falls into the condition where the object is in the middle. For the too far check, we're going to check if dist is greater than 70 millimeters. Now, if it is too far, we want the robot to drive forward because the object is too far away. In the else if condition, we want to check if it is too close, for which we will check if dist is less than 30 millimeters. In this condition, we want the robot to drive reverse because the object is too close. Otherwise, the object is in the acceptable range and we land in the else case. Here we want the robot to stop driving. This works because every distance value falls into one of those three cases. That middle zone is important because it prevents the robot from constantly moving when the object is already at a good distance. Let's test it. Right now, the object is far away, so the robot moves forward. When I bring the object too close, it backs away. And when I hold the object somewhere in the middle, the robot stops. That means our logic is working. You can tune this behavior by changing the thresholds. If I increase the upper threshold, the robot waits longer before moving. And if I increase the lower threshold, the robot stays further away from the obstacle. This upper threshold decides how far is too far for the robot, and the lower threshold decides how close is too close. This is a great way to experiment and see how small code changes affect behavior. If you want a beginner-friendly way to practice sensor logic in VEX IQ, this is a great project to try. You learn variables, conditions, and how to define a target zone using real sensor data. In the next video, we can make it more smooth by controlling how the robot's speed varies in proportion to the distance to the obstacle. Until then, happy programming, and I'll see you in the next one.